Welcome to Glad Labs Podcast. Today's episode, NIST SP 1800-35, a practical guide to zero trust implementation. For decades, network security operated on a simple principle: build a strong perimeter like a castle and moat to keep threats out. But this approach is becoming increasingly ineffective. The growth of cloud computing, the rise of remote work, and increasingly sophisticated attackers have made that perimeter porous. Once an attacker gets inside, they often have free rein. The National Institute of Standards and Technology, or NIST, addresses this challenge in Document SP 1800-35, outlining a zero trust architecture, or ZTA. This architecture fundamentally challenges the idea that everything inside a network should be inherently trusted. The traditional security model implicitly trusts users and devices already on the network. Zero trust, in contrast, operates on the principle of never trust, always verify. Every user, every device, every application, regardless of its location, must be authenticated and authorized before being granted access to any resource. This isn't just adding another layer of authentication. It's a complete shift in how security is approached. Organizations adopting these principles are finding they significantly reduce their attack surface and limit the potential damage from a breach, a particularly important benefit given the increasing complexity of modern IT environments. NIST SP 1800-35 doesn't dictate a specific set of technologies to use. Instead, it provides guiding principles and a conceptual framework. The core of this framework revolves around establishing a policy decision point, often abbreviated as PDP, and a policy enforcement point, or PEP. The PDP evaluates access requests, considering factors like user identity, device security, and the sensitivity of the data being requested. The PEP then enforces the decisions made by the PDP. This separation of concerns is crucial for building a system that can scale and be maintained effectively. Several key tenets underpin zero trust architecture. Data-centric security prioritizes protecting the data itself, rather than just securing the network around it. This involves implementing granular access controls, encrypting data, and using data loss prevention measures. Least privilege access ensures that users and applications only have the minimum permissions necessary to perform their tasks, minimizing potential damage if an account is compromised. Microsegmentation divides the network into smaller, isolated segments, preventing an attacker who breaches one segment from gaining access to the entire network. Continuous monitoring and analytics are also essential components. Zero trust requires constant assessment of risk and adaptation of security policies. This includes logging and analyzing user behavior, detecting anomalies, and responding to threats in real time. The document emphasizes the importance of automation in this process, as manual analysis simply isn't scalable in today's threat landscape. This continuous assessment aligns well with the principles of DevSecOps, integrating security practices throughout the entire software development lifecycle. Implementing zero trust isn't about completely overhauling existing systems. It's a journey, and organizations can adopt a phased approach. A crucial first step is defining a clear scope. Identify the most critical assets and prioritize their protection. For example, a financial institution might start by securing access to customer data, while a healthcare provider might focus on protecting patient records. Several technologies can be leveraged to build a zero trust architecture. Identity and access management, or IAM, solutions are foundational for verifying user identities and enforcing access controls. Multi-factor authentication, or MFA, adds an extra layer of security, making it harder for attackers to compromise accounts. Endpoint detection and response tools monitor devices for malicious activity and provide rapid response capabilities. Software-defined perimeters create secure, dynamically provisioned connections between users and applications, effectively hiding infrastructure from unauthorized access. However, technology alone isn't enough. A successful zero trust implementation requires a cultural shift within the organization. Security teams need to collaborate closely with business units to understand their needs and ensure security policies don't hinder productivity. Developers need to embrace secure coding practices and integrate security into their workflows. Even small teams can benefit from zero trust principles by focusing on automation and prioritizing the most critical assets. One of the biggest challenges with zero trust is its complexity. Implementing granular access controls and continuous monitoring can be resource-intensive. Many organizations struggle to balance security with usability. Striking the right balance requires careful planning and prioritization. Consider leveraging existing infrastructure and tools whenever possible. If you already have a robust logging and monitoring system, integrate it with your zero trust implementation. Cloud-based security services can also help reduce the burden on internal IT teams. And again, automation is key to managing the complexity of zero trust, automating tasks like user provisioning, access control enforcement, and threat detection. For solo developers or small teams, a pragmatic approach is essential. Start with the basics: strong authentication, least privilege access, and regular security audits. Utilize open-source tools and cloud-based services to minimize costs. Focus on protecting the most critical assets and gradually expand your zero trust implementation over time. From a developer's perspective, tools like Fast API can facilitate the implementation of secure APIs with built-in support for authentication and authorization. Building a robust API layer is crucial for enabling fine-grained access control and ensuring data integrity. Consider integrating Cloudflare email service to secure communications and enhance authentication workflows. Implementing a zero-trust architecture is a complex undertaking, but the benefits, reduced risk, improved security posture, and enhanced compliance, are well worth the effort. Don't try to tackle everything at once. Start small, prioritize your most critical assets, and focus on implementing the core principles of zero trust. Begin by conducting a thorough risk assessment to identify your most vulnerable areas. Then, develop a phased implementation plan, starting with a pilot project. Continuously monitor and evaluate your progress, and adapt your approach as needed. Embrace automation and leverage cloud-based security services to streamline your operations. The guidance in SP 1800-35 provide a solid foundation for building a robust and effective zero-trust architecture. Remember, security isn't a destination, it's an ongoing journey. Thanks for listening to Glad Labs podcast. Visit gladlabs.io for more episodes, articles, and insights. See you next time.